Good afternoon, class. We are looking at exam 3 review covering from section 3.5 to 4.2. And here's the second half that we are going to look at. Example 10, find the absolute max and minimum values of f on the given interval, where f of x is x squared minus 1 quantity cubed in the closed interval of minus 1 to 2. So we use the closed interval theorem, which means we have to know what type of function and whether it's continuous or not. This is a polynomial of degree 2 times 3 or 6. Every polynomial has a domain of negative to positive infinity, which makes it continuous from negative to positive infinity. Therefore, it's continuous in the given interval of minus 1 to 2. So it's a polynomial of degree 2 times 3 equals 6. And now we can go with the methodology, and we are going to find critical points by finding f prime of x. To find f prime of x, we put the 3 in front, and then x squared minus 1 to the power of 2. We are using the extended power rule. And then by the chain rule times 2x, we multiply these two pieces. 6x, we put it in front. And we want to set this equal to 0. When we do that, x becomes 0, x squared becomes 1 or plus minus 1. So please understand, this gives us x equal to 0. This gives us x squared equals 1. There are 3 answers. Now also, we have to look at f prime does not exist. F prime is itself a polynomial of degree 2 times 2, 4 plus 1, 5, or you can look at it here. A polynomial of degree 5, and the domain is all real numbers. So f prime doesn't exist, doesn't produce anything. Let's check those values. Is negative 1 in between? Well, it's one of the endpoints. Is positive 1 in between? Yes. Is 0 in between? Yes. We are going to evaluate the function at the endpoints as well as the critical points. Negative 1 and 1, those are easy to evaluate. If I put negative 1 or positive 1, makes no difference. When you square it, you get positive 1. Minus 1 is 0, 0 cubed is 0. So these two result in 0. If I plug in 0, I get negative 1 cubed, which is negative 1. If I put 2, I get 2 squared, 4 minus 1, which is 3, cube it, I get 27. Here's the absolute max. Here's the absolute mean. So absolute max is 27 at this pair. Absolute mean is negative 1 at this pair. We are going to write absolute max equals 27 at 2, 27. Absolute mean equals negative 1 at 0, negative 1. So that's pretty straightforward, everybody. A small rock is dropped into a lake. Circular ripples spread over the surface, with the radius of each circle increasing at the rate of 3/2 feet per second. Find the rate at which the area of a circle is changing when the radius is 4 feet. First, we have to have information about the circle. So this is the diameter. This is the radius. The area is equal to pi r squared. The diameter is 2 times the radius, and the circumference, that means going around it, is 2 pi r. In this case, we need the area equals pi r squared. So what is given? The radius is increasing at this rate, therefore dr dt is 3/2 feet per second. We are looking to find the rate at which the area is changing. We want to find dA dt when the radius is 4 feet. So this is the same question translated. We are going to differentiate this with respect to t. Please understand we are using, in essence, dy dt is dy du dt. It's using the chain rule. So you want dA dt pi is a number, is a coefficient, is a multiplier, remains, times r squared. R squared results in 2r dr dt. If we were taking the derivative with respect to r, just to r, but we are taking it with respect to t, that's why I want to pay attention to this, which is 2 pi r dr dt. Replace the r with 4, dr dt with 3 halves. We get 12 pi square feet per second, the units of area over the units of time. This is the exact answer. Then this is an approximation. You must always have your exact answer. And if they ask you to approximate it, then you use an appropriate number of decimals. A spherical balloon is deflating, losing 8 cubic centimeters of air per minute. At the moment when the radius of the balloon is 20 centimeters, how fast is the radius decreasing? We should know the shape of a sphere. We should know the volume is 4/3 pi r cubed, so we can move on. We're going to reread the question. It's deflating at this rate, so that means dV dt is negative 8 cubic centimeters per minute per unit of time. How fast is the radius decreasing? We are interested in dr dt. At what point where the radius r equals 20 centimeters? Again, translation of the question, everybody. So we are going to differentiate this. dV dt, remember, we are taking the derivative with respect to t. R is not an independent variable. So it's 4/3 pi, which is the multiplier, the coefficient, and now r cubed, 3r squared dr dt. We get 4 pi r squared dr dt. We replace the dV dt with -8 or with 20. This is 400. This is 1600 pi. We are going to divide both sides by 1600 pi. So -8 divided by 1600 pi gives us dr dt. 8 cancels out the 16. And we get -1 over 200 pi. So dr dt is precisely -1 over 200 pi, -1 over 200 pi, units of the radius over the units of time, centimeters per minute. Again, for decimal representation, if they ask, this is a must. If they ask, however many decimals they ask. That's why I always put a lot of decimals unless otherwise mentioned. Example 13, graph f of x equals -x cubed plus x squared plus x. And here's the steps that we have discussed. And we add to algebra and pre-calculus step. What I want to do, I want to quickly graph this just using algebra and pre-calculus steps. And then we add the first derivative test for more information, and then the test of concavity. So for now, in order to graph it using simply algebra pre-calculus, let's find the intercepts. Therefore, I'm going to factor out the negative x out. I get x squared minus x minus 1. And let's set this equal to 0. When I do that, x becomes 0. And x squared minus x minus 1 is 0. And to answer that, I need the quadratic formula, x equals minus b, plus minus the square root of b squared minus 4ac over 2a. So a is 1, b is negative 1, c is negative 1. And here's the answers. Minus b makes it minus negative 1 or positive 1, plus minus the square root of b squared minus 1 quantity squared minus 4 times a times c. So this is 1. This is positive 4. They add up to 5 over 2. Therefore, the intercepts are as follows: 0, 0, 1 plus square root of 5 over 2, comma 0, 1 minus square root of 5, comma 0. It's really a good practice to show in pairs so we know what we are dealing with. Let's graph. To do so, square root of 5 is about 2.2 and 1 is 3.2. Roughly divided by 2 is 1.6. And I do that for the sake of graph. So this is 1.60. 1 minus square root of 5 divided by 2 becomes a negative 0.60, so roughly here. And of course, the easy one, 0, 0. By no means this is to scale. Leading term minus x cubed. That means these arrows. That means the second and the fourth quadrant. So each one, by the way, each x-intercept, it's degree 3. There are 3 x-intercepts. Each one has multiplicity 1, and therefore, as we get to the x-intercepts, it crosses the x-axis. All of them have odd multiplicity, more specifically 1. So over here, we get to the first x-intercept, we bring it back up. The second intercept, we have to bring it back down. The last intercept, here's the graph, and this is a rough sketch. As far as algebra and pre-calculus is concerned, normally we would pick a couple more points to be on the safe sides. But this is the graph and we're done. However, we are going to go with the first derivative test. So I'm going to erase this and graph it with more details. My point being, we could have done it without calculus. It wouldn't look as good, but it gives us an idea. So f of x is minus x cubed plus x squared plus x. Therefore, f prime is minus 3x squared plus 2x plus 1. We need to set this equal to 0, so I'm going to factor the negative sign out. I get negative outside the parentheses 3x squared minus 2x minus 1. And to factor this, actually, it's pretty simple, because 3 is a prime number, so it's 1 and 3. And this is negative 1. So we have to have 1 and 1. One of them must be negative. When we put it in this format, notice this is minus 3x. This is plus x. And it gives us the middle term of minus 2x. I'm assuming everybody's comfortable with the factoring. So when you set this equal to 0, you get x equals 1. And over here, you get x equals negative 1/3. We are going to go with the sign graph, which means we have a number line from negative to positive infinity. And we put these two numbers in order from smallest to larger. So first, negative 1/3, f prime is 0. Second, number 1 is 0. And we have to do the pick up the TPs, test points. Before we do that, please understand f prime has two answers, is of degree 2, so they must alternate, or you can look at this one. Each one has exponent odd, exponent 1, which is odd, so they will alternate. The TPs, test points, everybody, in between the easiest would be 0. To the left of negative 1/3 would be negative 1. To the right would be 1. And if you plug in 0 into f prime, becomes positive 1. So it's positive here. And as I mentioned, they will alternate. The reason they will alternate, because we have two answers, two distinct answers, and they must alternate. But you can plug in negative 1 into this one or this one. You can put positive 1, and you see what happens. All right. So we have to plug in these points into the original function. Before we do that, what do we have here? Let's look at the arrows. Arrow down, arrow up. This is the location of a local mean. Arrow up, arrow down is the location of a local max. So therefore, if I put these two into the original function, 1 is easy. If I put the 1 here, I get minus 1 plus 1 plus 1, and I get 1. So when I plug in 1, the answer is 1. So local max is 1 at the pair 1, comma. I plug in negative 1/3 and I work it out. So I get minus negative 1/3 cubed plus negative 1/3 squared minus 1/3. Now negative 1/3 cubed is negative 1 over 27. This makes it positive. Plus this becomes positive 1 over 9 minus 1/3. 27 is the LCD, the least common denominator. So this becomes 3 over 27. This becomes 9 over 27. So 1 plus 3 minus 9 results in minus 5 over 27. Therefore, your local minimum is equal to this at this pair minus 1/3 and minus 5 over 27. Furthermore, we go back to this and we notice this is positive, which means it's increasing from negative 1/3 to 1. This is negative. This is negative. So it's decreasing from negative infinity to negative 1/3, union 1 to infinity. To continue, we're going to put all the information that we got on the previous page here. We have the function, we have f prime, we have all the intercepts, we have the max equals 1 at 1, 1. We have the mean equals minus 5 over 27 at negative 1/3 and negative 5, 27. Increasing from negative 1/3 to 1, decreasing from negative infinity to negative 1/3, union 1 to infinity. So this is all the information from the previous page, nothing brand new. So to find inflection points, we're going to go with f double prime, which is minus 6x plus 2. And we set that equal to 0. X becomes 1/3. When you set this equal to 0, class, That means 2 equals 6x, and x is 2 over 6, or 1/3. We go with the sign graph. That means on a number line, we're going to put negative to positive infinity, and there's only one point x equals 1/3. We put it there. At x equals 1/3, f double prime is 0. So we go with TPs, test points, and to the left of 1/3, the easiest point would be 0. To the right would be 1. And as long as you get one of them, it alternates. So 0, if you put it back to into f double prime, makes it positive 2. So it's positive here, negative here. If you have doubts, put the 1 and you get minus 6 plus 2, which is -4. So positive, negative. Positive means what? Concave up. It is concave up from negative infinity to 1/3. Concave up from negative infinity to 1/3. Negative, what does it mean? Concave down from 1/3 to infinity. Furthermore, because of the change in sign, x equals 1/3 is the location of IP, the inflection point. So you have to put it back into the original function to find its y coordinate. We do that. Minus 1/3 cubed plus 1/3 squared plus 1/3. This is 1 over 27. This makes it negative. This is 1 over 9. This remains at 1/3. Again, 27 is the common denominator. So this is -1. This is 3 over 27. This is 9 over 27. So -1 plus 3 plus 9 makes it 11 over 27. So the inflection point is located at x equals 1/3, y equals 11 over 27. We are done with all the information. We are ready to graph. I like to write a summary table. And in that summary table, I have all my intercepts, max and mean, IP, and so forth. So x-intercept 0, 0 is here. X-intercept 1 minus square root of 5 over 2. I'm going to go with the decimal notation for the sake of graph. So about minus 0.6 roughly. So it's here. 1 plus square root of 5 over 2 is about 1.62. So somewhere here. Maximum is located at 1, 1. So here's 1. Here's 1. So somewhere here. Because it's a maximum, it's a smooth curve, and we are going to go with a double-sided arrow, meaning the graph can't cross it. The IP inflection point is located at 1/3, 11 over 27. We go with the decimal representation for the sake of graph, about 0.3 and 0.4. So somewhere here is about 0.3, somewhere here is about 0.4. So put them together. That is the location of IP. The minimum is located at negative 1/3, negative 5 over 27, roughly minus 0.3, minus 0.2. So somewhere here is minus 0.3, somewhere here is minus 0.2. So putting it together, we get to this one. And again, we go back, we say it's the minimum. So we go with a double-sided arrow, meaning it can't cross that. Going back to f of x, remember minus x cubed indicates as the leading tail, indicates the end behavior, second and fourth quadrant. So you put the graph together, notice where the function is decreasing, increasing, decreasing, local max, local mean, all the intercepts, IP. So the function is concave up here, concave down here, Every piece of information can be shown on the graph. And in essence, it can be observed. A 20-foot ladder leans against the building. The base of the ladder slips away at the rate of 2 feet per minute. Find the rate of change of the height of the ladder when the base is 12 feet from the building. Here's the setting, here's the drawing. So here's the building or the wall. Here's the ladder. It's moving this way, creating this shape, which is a right triangle. And it's coming down this way. The ladder is fixed at 20 feet. So as it moves this way, the speed or the rate is 2 feet per minute. As it comes down, the speed or dy dt is missing. We are looking to find that. Again, notice this is a right triangle. Pythagorean theorem says a squared plus b squared is c squared. Therefore, x squared plus y squared is 20 squared. Dx dt is 2 feet per minute. Dy dt is missing at what point? When the base is 12 feet, when x is 12 feet. So this is the translation of this along with the setting. We are going to differentiate. X squared becomes 2x dx dt because t is the independent variable. Y squared is 2y dy dt, any number. We know 20 squared is 400, any number results in 0. We have everything we can plug in except y. So if we put the 12 into Pythagorean theorem, at the moment when x is 12, we can find the y value. So x squared plus y squared is 20 squared. 12 squared plus y squared is 20 squared. So you subtract 144 from 400, 256. And you take a root. There are two answers. You keep the positive value, y equals 16 feet. We go back to this, and we, into this equation, we replace the x with 12, dx dt with 2, dy dt is missing, y with 16. 2 times 2, 4 times 12 is 48. 2 times 16 is 32. We are going to move things around. And we're going to say 32 dy dt is negative 48 because this has to move. Divide by 32, both numbers are divisible by 16. We get negative 3/2 feet per minute, units of y over units of t or time. Notice x is increasing, getting larger. Dx dt must be positive. Y is decreasing, meaning it's getting smaller. Dy dt must be negative, and it's indicated here.